how do you start to educate somebody where to look and what to look for in regards to analyzing science?
Okay, so first, I think kind of a meta topic of the webinar is going to be how deep do you dive into anything in life, whether it's a research or a training program or a nutrition program, and sort of the idea that if you are just learning to swim, don't go free diving in the ocean with sharks kind of thing. You want to wade in. So the same with reading science. If you're brand new to nutrition or if you're brand new to science in general and you want to know more about nutrition and training, I think the best place to start is a textbook. And then once you have a nice fundamental knowledge base, then you can start sort of dipping into the science. Because the thing is, if you're going to PubMed and searching something, the fundamentals are very rarely researched anymore because they're fundamentals. They've been established and everyone agrees upon them and they're in textbooks, and the only scientific articles about them are, 30 years old, and they're going to be harder to come by. And any recent articles are going to be researching like tiny little details that might not apply to your needs yet as a brand new, someone who's brand new into science and fitness. Once you feel like you have a good fundamental knowledge base, I think then you can start looking at primary articles. And I'd say my best mini tip for that is first thing you do, look at the subjects that were used. So it's particularly for training. Make sure that the subjects you're looking at apply or will, the subjects you're planning to apply the information to match the subjects in the study.
I think people gloss over, we call it abstract hunting, where
Right.
you'll read maybe the introduction to the article. You'll read the article title. You'll be like, oh, this applies to what I want it to apply to.
Right.
And then you'll go straight to the conclusion in the abstract, and you'll gloss over all of the methods. And
Right.
it sounds
Exactly.
it sounds like that's kind of what you're getting at is you got to look at, does the patient population apply? Is it externally valid to what you're even
Right.
asking?
So as an example, so one thing to keep in mind too is when, as a researcher, you know that if you want to get your stuff published, you need a sexy title. So a lot of times the title and the abstract are going to be much sexier than the actual data and conclusions. So when you're seeing that, know that the researchers chose that title to get attention to their paper and get it actually published. So if you're, for example, if you're training like older women who have been in weight training for 10 years and you find a conclusion based on untrained college-age males, you're going to have radically different results in that population than you will in the one you're looking to apply the information to. So just an example of how that can go wrong.
Do you also find you mentioned the conclusion and the title are going to be more sexy than the actual statistics in some cases. I see this in research that applies to rehab in that the conclusions state that the information was, or the data was statistically significant, and they take that statistical significance and they run with any and all narratives that they want to run with to make it sound really important and big. And so it's like, these are the results of this landmark study, this type of thing. But when you actually look at the data, it's like, is that even clinically relevant? It was statistically significant. Does it mean anything, though? It was such a small effect size, or it was a small change or something like that. Do you see that type of thing happen with nutrition research as well?
Oh, definitely. Yeah. And you'll see things like, for example, I don't know if you know about that. There's some cohort studies a while ago associating sugar-free sweeteners with obesity. And so their big conclusion was, Splenda causes obesity, which doesn't really make any sense in terms of physics, but they had this really strong association. It was statistically significant. People who were eating Splenda were more likely to be obese. But they sort of, I'm not sure if it was a scientist fervor to get published and have, this crazy controversial title, or if it was just a blind spot for them. But the alternate conclusion, which is obviously makes more sense and more data has come out to support, is that people who are obese are eating more sugar-free sweeteners because they're trying to lose weight. So
confounding factors that we're getting into.
Yeah.
Well, and popular media will take that conclusion and run with it. And that's why that stuff.
And they're still running with it, despite the subsequent literature that came out and said, nah, that's probably not quite the case. They did controlled studies where they had people eat, drink sugar-free sweetener or plain water, and guess who lost more weight?
Yeah.
But yeah, there's still, Popular News is still publishing that as if it were true.
There's been tons of stuff like that. Chocolate cures disease, and eating breakfast.
Smelling farts cures cancer.
Right.
My favorite.
Yeah, unbelievable. Yeah. So I want to go back to something you said in regards to the first place to start, because we're kind of getting down the rabbit hole of like, what's a confounding factor and all these things. But if you're somebody that doesn't have that background, at least what you're saying is try to at least match the demographic of the study with the demographic that, or you, if you're trying to apply it to yourself. Okay, we've got that. In regards to textbooks, do you find any downside to textbooks in that my concern with textbooks is that they're biased towards the author, because the author's kind of interpretation of whatever they're talking about. And with books, when the book is finally published, it's usually having been written a year ago, or maybe even 2 years ago, so it's like they're already ready to update the book and something like that. So do you preface that at all in regards to weaknesses of even textbooks?
There's definitely weaknesses to textbooks, but I think the updates that will be made to a textbook or the changes that happen within a year or two are going to be with regard to details. Like, I doubt there are any textbooks in the last 10 years that say don't eat protein. You know what I'm saying?
Right.
So if you're really at the start of delving into this information, I think it's still a good place to start. Recognize that there might be updates to the details, or that it might not be completely exact, but that the basics and the fundamentals will give you a good background from which to dive into reading more updated scientific literature with a more skeptical eye. Because if you go straight to PubMed and read, a nutrition article, you might not even have an idea of, what a carbohydrate is, or, some basics like that. So it really just depends on where you're coming from and how much fundamentals you're lacking before going into scientific reading.
So your thing is the textbook is a nice synopsis of things that are pretty well established. Like, we're not worried about the second edition telling us that protein actually has 12 calories per gram or something like that. Like, these things are pretty set in stone.
Or like,
so yeah,
0.8 times body weight versus 1 times body weight should be eaten, things like that. But you'll just get a general idea, and then you can sort of decide for yourself what to believe when you dive into the literature, and you can hone your view.
That makes perfect sense.